Let us explore what we have selected as the dimensions for the computational thinking. Why do I say we have selected? Because many authors have tried to distinguish which are the exact dimensions that we have to include in any computational thinking model. Let me just give you three main words that are algorithms, problems, and data. So if you think of a computer doing things, it's always going to be some algorithm working on some problem with lots of data. So if we see these three main pillars for the dimensions, then we can try to put like smaller names or subtasks that belong to one of these three domains. So in the whole intersection, we can talk about abstraction and pattern recognition, because you can recognize some problem that you already solved, you can recognize the data that you have already seen, or you can recognize some algorithm that you're going to do again. With abstraction, there's no problem to understand the abstraction in all three settings. If we go to the intersections, let's go first to data and algorithms. We can simulate through an algorithm how we obtain data. So we can simulate different data, and we can give data to simulate algorithms. We also have problem decomposition, algorithm decomposition. We have modeling. We can model the data, we can model the real world, we can model the problems. And if we look at each of these dimensions in a separate way, we can understand in the algorithms the typical implementation, parallelization, and debugging tasks. While in the problems, you can understand induction and deduction, the same that we will see in a mathematical setting. And regarding data, we have very particular dimensions that belong only to that set, that will be collecting the data, representing the data, and of course, analyzing the data that you have collected.